Limit is y goes to pi over 3 of sine of y minus sine of 2y divided by 2 cosine squared of y plus 3 cosine of y minus 2. The first thing we're going to do is try plug a pi over 3 in for each of the y's. So in the numerator, that will give us a sine of pi over 3 minus a sine of 2 pi over 3 divided by 2 cosine of pi over 3 squared plus 3 cosine of pi over 3 minus 2. The sine of pi over 3 is a root 3 over 2. A sine of 2 pi over 3 is also a root 3 over 2. And they're subtracting each other. Over 2 times the cosine of pi over 3 is a 1/2 squared, plus 3 times cosine of pi over 3 again is a 1/2, and then minus 2. So in the numerator, root 3 over 2 minus root 3 over 2 is a 0. In the denominator, we will have 2 times 1/2 squared, which is a 1/4, plus 3 times 1/2, which is a 3/2, and then minus 2. 2 times 1/4 is 2 over 4, or 1/2, plus 3 over 2, minus 2. 1/2 plus 3/2 is 4/2, or 2 minus 2. And we're ending up with the 0 over 0 indeterminate form. This is resulting from a trinomial quadratic involving cosine in the denominator and then sine functions in the numerator. One of the sine functions in the numerator is sine of 2y, and we may want to make use of the identity that sine of 2y is to sine y cosine y for that. And by putting that in place of the sine of 2y, we have a factorable expression in the numerator, and in the denominator it's a trinomial quadratic, so we should be able to factor that. So we have limit as y goes to pi over 3 of sine of y minus 2 sine y cosine y divided by, I will leave the denominator alone for now. We still have 0 over 0, but we have factorable expressions, and we're going to attempt to factor them now. So limit is y goes to pi over 3 of. In the numerator, we have a common factor of sine of y, leaving us with 1 minus 2 cosine of y. In the denominator, we have a trinomial quadratic, so this will factor. One of the factors has to be 2 cosine y, the other one will have to be 1 cosine y, so we get a 2 cos squared y. We need two numbers that multiply to be a negative 2. Well, that's certainly a 2 and a 1, and we just have to decide where to put the 2 and the 1. If we put a 2 here and a 1 here, we're going to get a 2 and a 2, which is a 4 or a 0, but we have a 3, so it doesn't look like the 2 and the 1 go that way. Maybe a 2 and a 1 like so. That will give us a 4 and a 1, and those can combine to be a positive 3 under the condition that this is a positive 2 to make a positive 4, and that's a negative 1 to make a negative 1. Now, as y goes to pi over 3, cosine of y is 1/2, and so it's the factor here and here that are making the 0 over 0. We need to cancel those. They're opposite sign of each other right now. So our next step is to be factor a negative out of one of them. Doesn't matter which one, though. I'm going to opt for the numerator. The negative will just sit in front of the entire expression, and that will change it to be a positive 2 cos y and a negative 1, which nicely matches the exact factor we see in the denominator. And we can cancel those factors out, and those are what we're making the 0 over 0. So we should no longer have the 0 over 0 indeterminate form. I'm just going to rewrite what we do have left. And now that we no longer have the 0 over 0 indeterminate form, we should be able to plug in the pi over 3 for the remaining y's. And that will give us the negative sine of pi over 3 divided by the cosine of pi over 3 plus 2. The sine of pi over 3 is a root 3 over 2. The cosine of pi over 3 is a 1/2. Now in the denominator, we will need to combine those fractions by a common denominator. I'm going to need to multiply the second fraction by a 2 over 2 so that it becomes a common denominator. And we will have 1 over 2 plus, and that 2 can be thought of as 2 over 1, plus 4 over 2 after multiplying. So we have a negative root 3 over 2 divided by a 5 over 2. We add the numerators, put them over the common denominator. At this point, we have a fraction over a fraction, so our next step is to reciprocate the denominator fraction, which will be a 2 over 5, and multiply it with the numerator fraction. Now in this multiplication, we have a 2 in the denominator and a 2 in the numerator that can cancel each other out, leaving us with negative root 3 over 5.